Fluid dynamics quiz. A fluid exhibits a shear stress of 25 Newton per meter square under a constant velocity gradient. If its structural behavior is mathematically modeled as tau is equal to a du by dy to the n plus b, where b is not equal to 0 and n is less than 1, how is this fluid categorized and what is a classical real world example? Is it diluent fluid quicksand or pseudoplastic fluid rubber solution or thixotropic fluids, printer's ink or rheopactic fluids, gypsum solutions? Answer is thixotropic fluids, printer's ink. The given rheological parameters are n less than 1 and b is not equal to 0. According to fluid typology matrix, a fluid with a non-zero threshold yield stress b is not equal to 0 that exhibits a flow behavior index less than unity and less than 1 is classified as thixotropic. Its viscosity decrease over time under sustained shear strain. Printer 6 and enamels. During an experiment at the MIT Mechanical Lab, a clean glass tube is inserted into a dual layer fluid interface where a water layer supports a lighter oil layer of density rho b. What is the correct mathematical formulation to evaluate precise capillary rise or depressions H? S is equal to 4 sigma cos theta by rho GD or H is equal to 4 sigma cos theta by rho minus rho b GD. H is equal to 2 sigma cos theta divided by rho plus rho b GD. H is equal to 8 sigma cos theta divided by rho minus rho b GD. Correct answer is B 4 sigma cos theta divided by rho minus rho b GD. In a standard single fluid system exposed to the atmosphere, capillary action balances surface tension forces against the fluid column weight. With dual fluid layers, when a lighter fluid layer of density rho b rests on top, the bind resistance changes the net gravity components requiring the density sigma rho to be replaced by terms rho minus rho b. So H is equal to 4 sigma cos theta divided by rho minus rho b GD. Which of the following statements completely and correctly describes the fundamental physical constraints separating an ideal fluid from a real fluid? A. Ideal fluid have zero surface tension, infinite bulk modulus, and are purely imaginary. Real fluids possess viscosity, surface tension, and finite compressibility. Real fluids have an infinite bulk modulus at 40 celsius. Ideal fluids have a finite compressibility driven entirely by temperature dependent molecular coefficients. Both ideal real fluids show zero surface tension and halos when passing through a narrow glass tube. Correct one is A. Ideal fluids have zero surface tension, infinite bulk modulus of purely imaginary. Real fluids possess viscosity, surface tension, and finite compressibility. By definition, an ideal fluid is assumed to be entirely incompressible, meaning its bulk modulus is infinite, and non-viscous. It possesses absolute no surface tensions and is purely imaginary. Real fluids existing in nature experience in terms shear resistance, viscosity, surface tension at interfaces and possess finite compressibility. A pipeline engineer needs transports four distinct real fluids through an industrial circuits based on standard fluid mechanics classification. So, what is the correct sequence of these liquids arranged in strictly increasing order of viscosity? The right answer is option B: gasoline, less water, crude oil, castor oil. Viscosity lowest is gasoline. Highest viscosity is castor oil. Sequence is gasoline, water, crude oil, and castor oil. An industrial nozzle generates a continuous cylindrical column of liquids of diameter d. What is the internal gauge pressures developed within this geometry due to the surface tension sigma of the fluid interface? This is 2 sigma by d, as already discussed. The internal gauge pressure equation vary distinctly across structural configuration due to the geometry of the interface. For a spherical liquid droplet, P is equal to 4 sigma by d. For a thin hollow stroke, the bubbles cell with two interface 8 P is equal to 8 sigma by d. For a cylindrical liquid jet column, the structural mechanical equilibrium resolves to exactly P is equal to sigma by d.